Today we'll be going over some atomic structure theories of chemistry. Let's start off with J.J. Thomson. J.J. Thomson discovered the electron through his experiment called the cathode ray tube experiment. And this led him to come up with his plum pudding model. And in the process of discovering the electron, he also knew that electrons have a negative charge. So in his plum pudding model, he imagined a large spherically charged ball, sort of speak, sort of like the batter. And then in different places spread out, like chocolate chips perhaps, or in a chocolate chip cookie, we have negatively charged electrons scattered throughout. So in the whole, we have some parts of this cookie or plum pudding are positively charged, some parts are negatively charged, and this is what he called his plum pudding model. Now we also have Ernest Rutherford, who discovered the nucleus, and he knew that the nucleus had a positive charge, and he discovered this through his gold foil experiment. And he didn't come up with a theory about the atom, though. Now we also have Niels Bohr's models of the atom. What he surmised is that an atom is sort of like planets around the sun. We have the nucleus in the middle, like so, which he knew to be positively charged, and we have orbits around the nucleus upon which electrons as such are orbiting around. So if we have two orbits, then we have, let's say, two electrons orbiting around our nucleus here. So in words, electrons move around orbits around the nucleus. And they are attracted to the nucleus because of their different charges. Attracted to nucleus, since the nucleus is positively charged and the electron is negatively charged. And electrons also have their own energy. Thus, they won't fall into nucleus. No falling into the nucleus. Because he realized that if electrons didn't have their own energy or some other way to keep moving around, then they would simply be so attracted to the nucleus that the electrons simply go to the nucleus, and then you wouldn't have any electrons there. And so one way to think about this is like planets around the sun. The electrons can only move in their orbits and can't switch around or anything else. Now we also have the quantum mechanical model, which is basically the one that's accepted today. And what it does is it uses Schrodinger's equation. Schrodinger's equation. And what Schrodinger's equation tells us is that we can't know exactly where an electron is and its speed that it's traveling at a certain point in time. We can only know the probability of finding electrons or an electron in some area. So we might know that in area A, for example, we're more likely to find electrons than in area B, where the probability of finding an electron is much less. We also have what's called principal energy levels, which is basically where we'll find more or less electrons. Principal energy levels, call them N. And then we have sublevels L. So principal energy levels is sort of telling their basic distance from the nucleus. We have sublevels L, which is sort of the different areas within an energy level, within N, where electrons can be found. And then we have orbitals denoted by M sub L, and orbitals are basically they're what make up sublevels. And we have spin denoted by M sub S, and this is basically which way an electron is spinning. And we write these out, the principal energy levels, the sublevels, the orbitals, and spin, but in reality these are all just solutions to Schrodinger's equation. So in the quantum mechanical model, we don't have electrons moving around in set orbits around our nucleus. Rather, we have, let's say, our nucleus in the middle, and then we have our principal energy level, let's say 1, and then we have different sublevels, such as we have an area like so, where the first few electrons will be found, and then perhaps we'll have something like this, where the next few electrons, and then we have something that's more 3D as such, and then we move on to the second one. And in these regions, electrons are most likely to be found further away from the nucleus. So what you might see is sometimes they're shaded, so the ones with more shade rather than ones with less shade will have a higher probability of being near electrons. And it's sort of hard to draw it, but if you see a diagram of this with something like a nucleus in the middle and different kinds of orbitals such as this, where this is the 3D, or perhaps this, or if you get more complicated, it looks something like this, and so on. Then you'll know that you're talking about the quantum mechanical model. So to summarize, J.J. Thomson, he discovered electrons, knew they had a negative charge, and came up with the plum pudding model. And then he also discovered these things through the cathode ray tube experiment. Ernest Rutherford discovered the nucleus. He knew that it had a positive charge, and he discovered this through the gold foil experiment. Niels Bohr came up with his model of atom that is very similar to planets around the sun. Where electrons move in orbits, they're attracted to the nucleus, but electrons don't fall into the nucleus directly. They have their own energy, so they're able to stay in their orbits. And finally, we have the quantum mechanical model, where we have different kinds of levels, sublevels, orbitals, spin, and basically it's finding electrons is only a probability of electrons in any area. So we can't know for sure. And there's different kinds of levels and orbitals, which is basically different kinds of areas which we can find electrons. Some are more likely than others, depending on it's distant from the nucleus, and so on. So if we draw the plum pudding model, it looks something like this. Positively charged large sort of plum pudding, and we have small negatively charged pockets around. Ernest Rutherford, he didn't come up with a atomic structure theory. Niels Bohr said this is our nucleus. We know that it's probably charged. And we have orbits with electrons. Here I just draw 2 orbits, but you get the ideas. And these are similar to planets around the sun. The quantum mechanical model, we have our nucleus here, and we have our main principal energy level perhaps, and different suborbital levels. and so on.